sections, 1, 2, and 3 in chapter 6, and then we'll do a couple sections out of chapter 7. So the next test we take will actually be chapter 6 and 7, but we're not doing all of either one. So just bits and pieces. If you have a unit circle, that might be handy today. If you have one that you might need to pull out, we're kind of going back to that. On tests or quizzes, obviously I can give you blank ones to fill out, but you don't get to bring one that's already filled out. So make sure you still know how to do those. If you need a blank one, I do have those up here, but you should have, remember we had the big one like on a whole sheet of paper, or we had several smaller ones. Today, I know a lot of you are getting ready to leave, track people, right? So I am starting this section. I am not probably going to get all the way through it today. The assignment, if you are checking that calendar in Classroom at all, there is a handout that will be posted on Classroom. Actually, I think I already posted it, maybe? No. This handout is due Wednesday. So tomorrow I will finish this section, probably do an intro to the next section, and then you'll have some time to wrap it up. So the assignment for both today and tomorrow is the 6.1 handout that I will post. To start us off, we're kind of going back to algebra for a minute. Do you remember in algebra we talked about functions, and if something is a function it has to pass the vertical line test. And then later on we talked about one-to-one. And what did it mean to be one-to-one? Must have had a horrible algebra teacher then. Oh, nobody has any idea. I feel real successful right now. So remember, functions are x doesn't repeat, passes the vertical line test. When we talked about inverses, we talked about one-to-one. It had to pass the horizontal line test. Y doesn't repeat. So in that, each x gives a unique y value. In simple terms, if it's one-to-one, y doesn't repeat. With our trig functions, okay, are they one-to-one? Do the y's repeat? Like sine of 30 degrees is 1/2. What's the sine of 50 degrees? Sorry, 150. Man, you guys didn't know what I was trying to say. 1/2. So is y unique there? No, it repeated. So our trig functions are not one-to-one. In terms of a graph, we know something is one-to-one if it passes the horizontal line test. But think about the graph of sine, for instance. We know sine looks like this. Does it pass the horizontal line test? No. If I draw a horizontal line, it hits this graph multiple times. So in general, the trig functions are not one-to-one. But we need to be able to find inverses. And inverses are what happens when you reverse x and y. So we have to kind of alter the definitions of our trig functions in order to find their inverses. Couple things to remember from algebra: when we find inverses, the domain of the original function is equal to the range of the inverse. Remember, the x's in the original become the y's in the inverse. The range of your function becomes the domain in the inverse. And when we look at the graph, because the inverse just reverses x and y, the inverse and its functions are symmetric across the line y equals x. All right. So the steps we used in algebra when we found inverses, we changed f of x to y, we switched x and y, solved for y, and replaced that with f inverse of x. So I have a few fill in the blanks in these notes. These were the steps in algebra. With our trig functions, we aren't going to have to go through this whole process of finding inverses. We really just need to define what they mean. So like we already said, our trig functions themselves are not one-to-one. But if I limit it, if I take a portion of the function, it would be one-to-one. So think about, for instance, sine. We know the graph of sine that I already plotted looked like this. Okay, but does it really start and stop there? No, it keeps going forever. And it goes this direction as well. So really, my inverse, I just need to have a section of the graph that shows everything between -1 and 1, right? My y values. If I just took this part of it, would that little piece be 1-to-1? Yes. So we will limit the domain of these functions when we talk about their inverses. With that, we can think about the unit circle and think about consecutive quadrants. Okay, everything is positive in quadrant 1, right? We basically need a positive quadrant and a negative quadrant close to one another. They have to be touching, so it's consecutive. So we can either go quadrant 1 and 2 or quadrant 1 and 4. If I'm talking about sine, it's positive in quadrant 1. Is it negative in 2 or 4? 4. So if I'm going to talk about sine inverse, I have to limit it to quadrants 1 and 4. Okay, remember sine is the y value. So if I just pick those quadrants, they're consecutive, and that would give me the inverse. So notation for an inverse trig function, it has sine to the -1, or you might see arc sine. Both of those mean sine inverse. The graph, I am not going to focus on the graphs a lot, or the exact points. That's kind of, it's good information. I put it on here, but what I'm really worried about is this right here. If I'm talking about sine inverse, which quadrants does it have to be in? And you have to have one positive and one negative quadrant. So it's positive in quadrant 1, it is negative in quadrant 4. That is the important piece of today. For every trig function, we need to know which quadrants am I talking about if I see the inverse. So sine is quadrants 1 and 4. The domain, we know sine itself has a range from -1 to 1, so that becomes the domain. My range, this is because I went from quadrant 1 to quadrant 4. All right, -π/2, that's the same as 3π/2. It's down here. So it's just saying you're going from -π/2 to +π/2. That's our quadrants that we're picking. A lot of times with these inverses, you will see it written as -π/2, -π/4 versus their coterminal. I don't really care. You should recognize, if I say -π/4, you should recognize that's in quadrant 4. All right, so if I look at this question, we have solved some problems before where I might say, find when sine is 1/2. But this is different because the original problem has arc sine. It's the inverse of sine. That means I can only get one answer. Now, sine inverse, when I see that, I know my answer has to be in either 1 or 4. Those are the only two quadrants sine inverse exists in. If it is positive, which of those two quadrants am I in? Quadrant 1. So what this is saying is when in quadrant 1 is sine equal to 1/2. So if you are thinking about your unit circle, I know I'm looking for sine 1/2, it's right here. Or you can think about your hand trick. When is sine 1/2? I didn't specify degrees or radians. Normally I would, so if I were in degrees, I would say 30 degrees. If I were in radians, I would say π/6. I'm never going to expect you to give me both of them. I'll just tell you in the directions which one I want, degrees or radians. So the difference of these problems versus the ones we've done before is if the original problem has an inverse or sine inverse or arc sine, you can only give me one answer. So we have to pick the correct quadrant. If I look at this, sine inverse of -1. So again, it's sine inverse. I know sine inverse can only exist in quadrants 1 and 4. If it's negative, which one would I be in? 4. So I'm saying when in quadrant 4 is sine -1? Sine, oh, remember sine of that would be radical 2/2. Yeah. Think about the unit circle. Sine is the y. Y is -1 right here. So, lots of different ways you can identify that angle. I didn't specify degrees or radians, so you could say 270 degrees or 3 pi over 2. The proper notation is to use the negative angles, saying -90 or negative pi over 2, but don't we already know those are the same? Yeah, so any of those answers are okay. You can express it in terms of any of them. We all know what we're talking about there. All right. Sine inverse of -2. I know sine inverse can only exist in quadrants 1 and 4. If it's negative, it would have to be quadrant 4. But sine can only equal things between -1 and +1. So can sine equal a -2? No, so this one's no solution. All right. Is that okay? So let's talk about cosine. Think about your unit circle. Cosine is positive in quadrant 1. When is it negative? Quadrant 2. So cosine inverse. The most important thing that I'm talking about today is the quadrants. Cosine inverse, when you see that, I am talking about either quadrant 1 or 2. Because you always have one positive quadrant and one negative quadrant. Domain is still -1 to 1 because cosine always equals values between that. The range, if we're going from quadrant 1 to 2, then your x's would be from 0 to 5. I'm probably not going to quiz you on the graph or the domain and range of the inverse functions. I really just need you to know what quadrants they exist in. Take a second and look at example 2 and see if you can figure out any of those values. So we did them for sine together. Try them for cosine. When I see arc cosine or cosine inverse, I know it's either quadrant 1 or 2. 1 is positive, so it's in quadrant 1. You can think about your hand tray, think about your unit circle. Cosine is the x value. When is x positive 1?
Track is dismissed at this time. Track is dismissed.
0 degrees. All right. Good luck. So this, cosine inverse of negative radical 2/2. So cosine inverse can be quadrants 1 or 2. In which quadrant is it negative? Quadrant 2. Come on in. You're just waiting for me to smack in.
Yeah. Yep.
Good luck.
No, that's not right. No, no, right. Dennis, I want you to sit right here. No, I have to concentrate. You're just distracted. I'll pull it in this. Yeah, pull it in this right next to it. Right across. I'll sit right there. Sit right there. Whoa. This one's fine. This one's fine. And my calculator. Sorry, just not good. I need a calculator.
Okay.
Daniel wants all three of us to survive.
Alright, so in which quadrants is it negative? 2. Alright, if you need to, you can think about reference angle. When is cosine radical 2 over 2? 45 degrees. So then 45 degrees in quadrant 2, 135. Alright, C, cosine inverse of 1/2. So cosine inverse can be quadrant 1 or 2, but it's a positive 1/2, so that would be quadrant 1. Reference angle, when is cosine 1/2? 60 degrees. So 60 degrees in quadrant 1 is just 60 degrees.
Can you send it back to my
Yeah.
Thank you.
You're welcome.
Good.
I won't.
When you guys finish with your video, feel free to come grab your handout if I'm still teaching. Alright. Yeah, just ignore it. The wasps like to stay up high. It'll be fine. Alright, so let's talk about tangent. Tangent is positive in quadrant 1, but it's negative in both 2 and 4, right? So technically we could do either. So let's think about when we graphed tangent. Tangent was the weird one. Where did we graph it so we had a nice solid piece? We went from negative pi over 2 to positive pi over 2. So we were already using quadrants 1 and 4. That's what we're going to stick with for tangent inverse. So tangent inverse is like sine. It will be quadrants 1 and 4. So you can fill in your blank domain and range. With tangent, we know the range. It goes from negative infinity to positive infinity, so that becomes your domain. The range of this is the negative pi over 2 to positive pi over 2, the section that we are picking. Okay, let's talk about cotangent. When we graphed cotangent, we went from 0 to pi. So which quadrants are those? 1 and 2. So cotangent will be quadrants 1 and 2. Does everybody have what they need from our tangent box? So cotangent last two, secant and cosecant. Secant is the reciprocal of cosine, so it's going to do what cosine did. Which quadrants did we pick for cosine inverse? 1 and 2, so that's what we're going to go with there. So secant. The domain of that is a little bit weird because the range of secant, remember, it only hits values smaller than -1 or bigger than 1. So that becomes our domain. In the inverse, and then cosecant's the reciprocal of sine, so what quadrants would it be? What quadrants did we pick for sine?
1 and 4.
Okay, so what you have to know from today are the quadrants. Everything is either 1 and 2 or 1 and 4. 1 and 2 is cosine inverse, secant inverse, and cotangent inverse. 1 and 4 is our sine inverse, cosecant inverse, and tangent inverse. And then the rest of it is just basically answering from the unit circle. So let's practice a couple more. I'd like to get through maybe examples 3 and 4. If I want the degree measure for the following, theta equals arctan of 1. So arctan, tangent inverse, as soon as I see that, I make a note to myself. what quadrants. So it's either 1 or 4. But 1 is positive, so that means I'm in quadrant 1. Reference angle if you want. Think about tangent. If you need to, you can go through your hand trick. Now, I'm looking for when tangent is 1. So that's the square root of the top over square root of the bottom. So that would be at 45 degrees. So 45 degrees and quadrant 1 is just 45 degrees. Okay, B. Theta equals secant inverse of 2. Secant is the reciprocal of cosine, so it exists the same places as cosine, 1 and 2. If it's positive, which of those quadrants are we in? If you don't like thinking about secant, you could think about the reciprocal of cosine, or reciprocal cosine. So this is looking when cosine is 1/2. So an inverse is giving me the angle. I'm saying tell me the angle on the circle when cosine is 1/2. Think about that. That would be at 60 degrees. So the inverse is giving me the angle here. Does everybody understand what we're finding? I want to talk about on your calculator. I do not want you to type in the negative angles. I want you to get a reference angle and put it in the correct quadrant. Here's why. If you type in a negative angle, you will get the right answer 2 out of 3 times. The problem is with cotangent. Because do we have a cotangent button on the calculator? No, we have to use tangent. But tangent inverse will give me an answer in quadrant 1 or 2, and if I'm looking for, will give me 1 or 4, but if I'm looking for cotangent, I need 1 or 2. And so if you try to use the calculator and you put in the negative, it will give you the wrong one there. So rather than trying to remember when it's okay and when it's not, we're just going to find reference angles on our calculator and then place it in the correct quadrant. So let's try a couple of these. You're welcome. Find y in radians if y is equal to the cosecant of -3. So what I want you to do is, we know cosecant could be 1 or 4. If it's a negative, I need the answer in quadrant 4, but we are going to get the reference angle. To do that, we do not have a cosecant button. So what we will do is sine inverse of, not -3, what would I have to do? If I'm doing sine. 1/3. Okay, I'm going to do a positive 1/3, so it'll give me my reference angle. Now, it says radians, so make sure your calculator's in radian mode. And then you hit, to get the sine inverse, you do second sine 1/3. You should get 0.3398. Did everybody get that? So to put it in quadrant 4, that's my reference angle. To get the real angle then, if you're in radians, you have to do 2 pi minus that. And that gives me 5.9434. Do you guys understand how we got there? So I did sine inverse of the positive to get our reference angle. So that's telling me this little angle here is 0.3398. So if you're giving me the rest, you would do 2 pi minus that. Alright, B, this time I asked for degrees, so go ahead and flip your calculator into degree mode. Alright, cotangent inverse can be in which quadrants? But it's negative, so it'd be quadrant 2. Reference angle, we don't have a cotangent inverse button, so you have to do tangent inverse of 1 over 0.3541. So second tangent, 1 divided by 0.3541. So I get 70.5009. How would I put that in quadrant 2? Remember we went distance to the x-axis, so we'd have to do 180 minus. And I get 109.4991 degrees. We are almost done with this, and I really could finish it now, but I want to give you guys some time to practice so you can ask questions. So there's a handout posted on Classroom. Tomorrow, I will take a few minutes and finish this. I will introduce the next section, and you will have some time to finish the handout as well, so it's due Wednesday. But I want you to get started now.